So we're on question number 4, which has a lot of parts to it. We do need to do the quadratic formula. So go ahead and read it and do part A. Write your set of parametric equations. So let's start with that. That's the easy part. So I'll give you a minute or so to write that. So in order to write your equation, you need to know the velocity, the angle, and the initial height of the object you are hitting. So the object that is being hit, that initial height is what? 3 feet. So the initial height is 3. So x equals 132 times the cosine of 45t. Your y parameter, because I'm using 32.2 for g, I'm using 32.2, I'm multiplying that by negative 0.5, which makes that negative 16.1 t squared plus 132 sine 45t plus 3, because it says suppose a ball leaves the bat 3 feet off the ground. So that's my initial height. That's my h sub 0. So that's part A. So we need to find the maximum height of the ball if it leaves the bat with a speed of 90 miles per hour. And again, 90 miles per hour converts to 132 feet per second. So let's figure out the maximum height. So what we're going to do, let's think about it. When we hit it, it's going to hit the ground. The maximum height is going to be in the middle. So what we need to do is find how long it's going to take for the ball to hit the ground. And when it's on the ground, that means the vertical height is 0. So we're going to use this parameter, and we are going to do the quadratic formula because we can't take out a GCF because we have an initial height that's 3. So the first thing we should do to make this easier is go ahead and type this in your calculator. So take 132 sine 45 and write that as a decimal so we can identify A, B, and C. And you should get 93.338 T plus 3. So this is your C. This is B. And this is A. So we have A, B, and C. And if you look on both sides of the chalkboard, I have the quadratic formula. So let's go ahead and do the quadratic formula. So to find on part B, so to find our maximum height, first we need to figure out how long it takes for it to return to the ground. So that's what we're trying to find now, is how long it takes the ball to return to the ground. And this is not factorable, so we have no choice but to use the quadratic formula. So that is x equals opposite of b, so that would be negative 93.338. And then we have to do this twice. You're going to do it with addition, and you're going to do it again with subtraction. Plus or minus b squared minus 4 times a times c. And that's all divided by 2 times a. So if you have a decent calculator, you can't do the plus and minus in once. You have to go through, do it with addition, get your answer, and then do it again with subtraction. But you should be able to type this entire numerator in one step, hit enter, divide it by 2a, get your first answer, and then do it again with subtraction. So take a couple minutes. I'll put up the answers you should get in about 2 minutes. So if you're not getting those answers, if you don't have a multi-view calculator, you're probably going to need to do it in steps, and you can't type it in at once. Or you may have to use more parentheses. So this 5.829 represents when the ball is going to hit the ground. But in part B is asking for the maximum height, which again, if we go back to yesterday, we know that the maximum height, or the vertex, occurs in the middle. So the first thing we need to do to find the maximum height is we need to figure out t in the middle. So to find t in the middle, we're going to take 5.829 and divide that by 2. And that's going to give you 2.915 seconds. So what do you think, where am I going to substitute that number to find the maximum height? X or Y? Not X. Y. Height is Y. Let's look at this. See how this here? This is a vertical distance. When we're talking about height, if I say how tall are you, I'm saying what is your vertical distance from the ground up. Okay, so height is vertical. So you need to take 2.915 and substitute it into your second parameter for t. So your maximum height we're still on part B. Yeah, part B says, oh yeah, so part B we have to figure out the maximum height. We still haven't found that yet. So the maximum height it's going to be y equals negative 16.1, and then we're going to take that t squared, and then plus, you can use this 93.338, or you can use 132 sine 45. Your answers may be a little different, but they'll be close enough. So go ahead, type that in your calculator to get your maximum height. And your maximum height would be what? What did you get when you typed that in? Yeah, I got 138.275. Go ahead and practice. Make sure that's what you get. So 138. So did you use, did you use this one here, or did you use the second one? For those of you, if you got 138, did you use the top one? For the 135, you used the bottom one, probably. That's okay. I mean, it's a little off. The most accurate would be the first one, but again, I wouldn't mark it wrong if you use so.
Yeah, I used the first one and I got 135. Because I used the one under maximum one.
Oh, okay, let me retype it in. Hold on. Wait, now I feel like I gotta make sure now. Hold on. Sine 45.
Oh, I didn't add 3.
Oh, there we go. You didn't add 3. Okay. So 138.275 feet. Because that was kind of a big difference. It shouldn't be. I don't know why I didn't. I should have clicked that was 3 off. So it didn't. Sorry. All right. So that's the answer. So we have finally reached the answer to part B. That's my answer to part B. So now go ahead and read part C and see if you can figure out what we have to do to answer part C. So now it's asking you for that horizontal distance. Do you see the difference in part C? Part C says, how far is the ball from the home plate at its maximum height? So we're still using T equals 2.915, except now we're going to substitute that in the X parameter. So I got to make some space. So part C, you need to take your X, and we're still using, because at its maximum height, T equals 2.915 at the maximum height. So 132 cosine 45, and multiply that by 2.915. Go ahead, type that in your calculators for your maximum, for the distance, the horizontal distance. And when I did it, I got 272.081. It's feet away. At max height. Yes.
Okay, so.
So for part D, it says, if the ball is hit straight down the left field wall, will it clear the green monster? If it does, how much does it clear the wall? So let's go to the very first sentence. How far away is that wall from the home plate? So we know the horizontal distance. And because we know the horizontal distance, we can solve for t using the x parameter. So let's go ahead and use that equation. Take 310, set that equal to 132 cosine 45t. Solve that for t. So you're simply going to divide both sides. So the time that it's going to take for it to clear, or not clear, but for it to reach the wall is going to be 310 divided by 132 cosine 45. And if you divide that in your calculator, I always feel like I got to recheck my answer. Let me recheck again, make sure. So 310 divided by 132 cosine 45. Yep, 3.321 seconds. So what we need to figure out is it going to go over the wall? Clear means, is it going to go over the wall? So I need to know the height at that time. So take your y parameter and find your y. And to find y, you're simply going to take this 3.321, you're substituting it in for t. So go ahead and do that. Take the 3.321 and substitute it in for t. So put it here and put it here to get your height. Or you have to put parentheses around your denominator. Trying to write it out, but I can't get it to fit. So you should get 135.408 feet, but it says by how much. If it does, by how much? So how tall is the wall? 37 feet. So to figure out how much, we're going to take that 135.408 minus 37. And it's going to say it's going to clear. So the ball is going to clear by, go ahead and subtract that. And you should get 98.408 feet. Bill, the concert promoter, used a t-shirt cannon to shoot some t-shirts into open windows of a college dorm. He is on a platform 60 feet. So is that 60? Is that his height? Is that a vertical or a horizontal distance? That's a horizontal distance. So write that down. 60 is how far away he is horizontally. That's really important because we can easily find T. Now it says that the t-shirt cannons are fired 10 feet above the ground. So that's your initial height. The velocity is 90 feet per second. The angle is 40. So go ahead and write your set of parametric equations for part A. Okay, so who had that for their equations? Okay, good. Now we know how far away he is, so this is a lot easier to do. So we can figure out, the first thing we need to figure out is how long is it going to take the t-shirt to travel 60 feet. And then after we figure out how long it takes for it to travel horizontally 60 feet, we can figure out the height at that time. So let's go ahead and find T. Because I know he's standing 60 feet away, let's take that 60 using your horizontal component, solve for T. Who got 0.87 seconds? So now let's see how high is it at that time? So if T equals 0.87, we need to see how high so we can figure out what floor it's going to reach. So take that 0.87, substitute it in for T in your Y parameter. All right, so for your height, you should have gotten 48.144 feet. So it's saying that in this particular college dorm, each floor is 10 feet. So I'm just going to say, okay. So this is the first floor, second floor. And this would represent 10, 20, 30, 40, 50. So what floor is it going to reach? The 5th floor. Because it's going to shoot, if it's going to reach a height of 48 feet, that means it's going to go right up at about there, which is the 5th floor. So it says, determine the floor that will receive the t-shirt, and it's the 5th floor. That is your final answer. So just a reminder, so that's the end of 10.7. Homework 18 is due Monday. If you have questions about homework 18, this is a good time to get those answered. We're really, really close to the end, so. And that's it. If you're doing a retake today, please remind me, because I don't think I know that. I don't think I wrote it down. So just remind me.